Right. Hello, everyone. So what we're going to look at today is investments. Now, investments is kind of the first kind of part of a larger kind of idea, which is kind of annuities or pensions. But we look at first of all just basic investments. Okay, so we've looked at investments in terms of compound interest, where you just put a lump sum in, you leave it, and it iterates over for a couple of years, and you get a bigger amount out. And the same with depreciation, which is just investment, but it goes back down. Today we're going to have a look at the idea of annuities. Okay, so this is where you feed in a certain amount of money. Okay, so if that makes sense to you, you feed in money regularly, and like an investment, you will compound it, but the compounding is a little bit different because the principle is changing based on, because you're topping it up every month. Because if you think of your original one, f is equal to p bracket 1 plus I to the power of t. So your p is always the same. You put it in at the start, and then all that's changing is, this is cycling, this is going through an iteration, and at the end of the first year, this p is a little bit bigger. Okay? But you still started with the same p. So you're just adding on to P before you start the next cycle of whatever this is, month, year, whatever. With regular, this P will be the same each time, but what will change is this, because it, the P for the T for the first installment of your money will never be the same as the T for the last installment of your money, because, well, naturally, your last installment of the money that you're adding in before you take it out won't be here for the same amount of time as the first installment you put in. So I suppose to clarify this and to put it into, let's have a look at a 5-year plan. So let's say we're going to save monthly for 5 years. We've got 5 years monthly savings. Okay, so if we're doing monthly, let's turn this into months. So 5 12 is 60 months. Okay, so after 60 months, what we should have is f is equal to p bracket 1 plus I to the power of 60 months if we're doing a monthly thing. Okay, that's what we should have. Okay, but the reality is, because this p is being put in every month, okay, it's not just one p going in and then waiting 60 months compounded, it's a p every month. Then what really is happening, okay, is the first p that's going to go in will be p bracket 1 plus I to the power of 60. Okay, the second month I go at will be p bracket 1 plus I. Now, I don't have 60 months left, I only have 59. So you see what's going to happen? The third month, blah, 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 blah. The fourth month, blah, blah, blah. The whole way up to the last month will only have to the power of 1, because they'll only have one cycle of interest, because they'll only gain interest for that 1 month. So we should have 60 of these in total. So if you think about it, what we're going to have is the first one plus the second one plus the third one all the way up to the last one. Okay, so we're going to have that kind of scenario. 60 of them. Now, for those of you who remember the chapter we did before, well, what are you actually doing there? Aren't you adding up? Yeah, you're adding a sum. But more importantly, look what it is you're adding up. If each of these represents a number or an amount of money, then this is a pattern, because it's only changing by a constant. And that constant, instead of being an addition or a subtraction, is a multiplication, which makes it a geometric pattern. In fact, it makes it a geometric series. And we're actually getting the sum of that geometric series, where we know the answer. So how do we visualize a geometric series? Okay, well, in order to get the sum of it, we have an SN formula. And if you remember, but it's in the log tables, the sum of a geometric series is a bracket 1 minus r to the n all over 1 minus r. Okay, so we just need an a, an r, and an n. Well, a will always going to be, in this case, a is the thing that's the same each time. Forget about the powers. The thing that's the same is this bit. Okay, so in this case, a, sorry, I want to try and get this all in. In this case, a is just going to be p bracket 1 plus I to the power of 1. Okay? Okay, because you're going to go up 60 times, we're going to start at 1. Okay? Now, let's try and work out the r. Well, it's only changing. So if I start there or there, probably best start there because the pattern is going up the ways. So if you start there, then the next one up is just, you're multiplying it by itself to get the squared version. You multiply 3 of them together to get the third month. You multiply 60 of them together to get that one. So it's just going to be 1 plus I, isn't it? Is the r value, the thing that's changing. If you're not sure, divide one by the other. Okay, if I divide this one, so we'll just check. So let's just check. If I divide p bracket 1 plus I to the power of 60 by p bracket 1 plus I power of 59, divide one by them, that's the only thing that's different. Okay, and then we need an n. Okay, in this case, n is going to be 60. So let's pop them all in, see what happens. So a 1 minus r, 1 plus I to the power of r to the power of n is 60, all over 1 minus r. 1 minus 1 minus 1 plus I. Okay, it looks very scary, but let's see what we can do with it. Okay, can't really see anything to be done with that. Okay, if let's see, can I do anything with this? I'm trying to see, can I do anything with this? Let me see. So that's just I on the bottom. Okay, can't really multiply that in, so I still have p bracket 1 plus I. Now, what can I do with this? Okay, so I can distribute the 60 over both of them, so that would leave me 1 minus 1 to the power of 60 plus I to the power of 60. Or I could just try and think, can I just move this around? Because I want this to decrease, don't I? So let me see, 1 minus r. Yeah, I could. I can have 1. So I'll multiply that. I'm going to have 1 plus I to the power of 60 minus 1. So that's my formula. So that gives you the final amount for any starting amount of money put in for n amount of years. Okay, now you're not going to get that in the log tables. I don't think. You have to derive it, and you could be asked to derive it, so just be aware of that. Okay, so it's not the hardest thing, but just be aware that you might have to derive it in an exam. Okay, so there we go. So here we go. We're going to give 1 or 2 of these a go just to see how we get on with it. Right, a special savings account offers 4% per year. If I invest £2,000 at the beginning of each year for 5 years, how much will my investment be worth at the end of the 5th year? Okay, so we're going to have to figure this one out. So I'll give you a second there now to think about that one if you want. have to. I'll go through it with you anyway, but be worth, as I say, trying. Right, so we've got a P, 2000. We have an I, which is 0.04, and we have a T, which is 5 years. So let's think what we're putting this together. So we've got P bracket 1 plus I, and we're doing this for 5 years. So the first year is obviously going to be, well, I can put it all into the formula, but let's just try and work it out if we were doing this the normal way. So the final amount would be, the first year would be 2000 by 1.04. Sorry, this would be the last year. And then the second last year would be 2000, 1.0. And then this would be this third year. Sorry, 2 grand, 2K is there, plus another 2K by 1.04 to the fourth, plus to the fifth. 1, 2, 3, 4, 5. So you'd have the 5 of them there. But listen, that's just crazy talk. We already know what the formula is. Okay, so we'll put it in. So it's P bracket 1 plus I. So that's 2000 bracket 1.04 to the power of 1 multiplied by big fraction 1 minus 1 plus I to the power of n, 1 minus 1.04 to the power of n or t. I keep calling it n because when I was a kid it was n, over 1 minus 1.04. Right. So just to show you, that's where it's coming from. So there's your P, 1 plus I. Okay. Let's give it a go. Let's have a go at this. 2000 bracket 1.04 multiplied by bracket fraction minus, thank God for calculators, oh, there we go, over 1.04. Okay, so I'm getting 11,265 euro and 95 cent. Okay, which is pretty cool. Right, try another one. So Anne has 65, 23, 33. Now that looks very awkward. Okay, 65, 23, 33. And that's after saving so much money at the start of each year for 5 years. And it was 9% per year. Write down a geometric series expressing the value of her investment at the end of the 5th year and then find A. Okay, so listen, our final value is going to be, well, listen, the first one, first year, plus the second year, plus the third year. I keep forgetting. 0, 9, plus the fourth year, plus the 5th year. So that's it. We're going to sum it all up. So we need to figure it out. So we know the answer. It was, what is it, 60, 65, 23, 33. We know that should be equal to one of them. So it should be equal to and times 1 minus 1.09 to the power 5 over 1 minus 1.09. So that's our same formula as the one above. Now, let's strategize here. Right. Isn't it just a matter of multiplying that and then dividing it into that? That's what it should be anyway. So listen, I'm going to try and do it all in one big boy job. Okay. 6523.33 divided by, in a bracket, 1.09 multiplied by 1 minus 1.09 to the power of 5 over 1 minus 1.09, and close that bracket, or you know what will happen. Hopefully this works. So they get an error. Okay, €999, 990. Okay, it's €1,000. I'm not going to argue. A is 1,000. Okay, you could write down 909, but listen, to the nearest, when you round that last digit to the nearest one, you know what you're getting. Okay, right. So that's a quick walkthrough of this. So what mainly comes up when you're doing with this is that SN formula, being able to kind of derive it. Okay, so if you just go back to the original, okay, it's a geometric series. Reverse it. You've got A, R, N. It's literally that. Okay.